In this video, you will learn how to calculate the surface area and volume of a cone. A cone is a three-dimensional figure that is pointed like a pyramid, however, its base is like a circle. So similar to how a prism and a cylinder are related, a cone is related to a pyramid in the same way. The slant height is still that length on the side that gives us that distance from the base to the vertex of the figure. Now, calculating the lateral area of a cone is not as straightforward as it was for a pyramid. If you look, it says here that by cutting a cone and laying it out flat, you can see how the formula for the lateral area comes to be. The lateral area is 1/2, it's like a triangle, the circumference of the base times the slant height, which forms because it is like that formula. Now, further simplifying the formula, if it's 1/2 times the circumference of the base times the slant height, we can simplify this even further to become, because the 2 cancels with the 1/2, our formula that we're going to focus on for lateral area that you should write down is the lateral area equals pi times the radius times the slant height. And then further, the formula for surface area is identical to the formula of surface area of a pyramid. It's the lateral area plus, now there's only one base, so it's plus one base. And finally, as you saw from your warm-up, the formula for the volume of a cone is that volume equals 1/3 the area of the base times the height. However, because it is a cylinder, I could simplify that further because the base is always a circle. So our base is always going to be pi r squared. So I could really rewrite this as v equals 1/3 times pi r squared times the height. However, in order to simplify the amount, we have to remember, focus on the fact that it's the volume equals 1/3 times the area of the base times the height. Now, in order to calculate the lateral area, surface area, and volume of the cone, we're going to follow the same process as we did for every other figure. First, we need to identify the base. So in this case, the base is a circle, and it has a radius of 5. So the base is pi times 5 squared, so the area of the base is 25 pi. The lateral area, we're now going to use the formula, so lateral area equals pi RL. So in this case, the radius is 5. L is that slant height, which we don't know because it is representative of this length right here. However, if we focus on the fact that we have a right triangle formed like we did for the pyramids, I can use the Pythagorean theorem to solve. So if I use my Pythagorean theorem, I'd have 5 squared plus 12 squared equals L squared. And if I simplify that, we get 169 equals L squared. And we take the square root of that 169, which gives us 13, which is, again, it's one of our Pythagorean triples, so we could use that as a shortcut as well. So rather than having L as unknown, L is really the length of 13. So now if I want to use the formula, I could say, okay, the lateral area equals pi times the radius is 5 times the slant height is 13. I simplify, leaving in terms of pi, so I get 65 pi inches squared is the first part of my answer. Now surface area equals lateral area plus the area of the base. So surface area is the lateral area is 65 pi plus the base is 25 pi. So if I simplify the 65 plus 25, I get 90 pi inches squared is your surface area. And lastly, volume is 1/3 the area of the base times the height. So in this case, we have volume equals 1/3 times the area of the base is 25 pi times the height of the figure is this vertical line right here. So the height is 12. So it's 1/3 times 25 times 12, which when you plug the 1/3 times 25 times 12 gives you a value of 100. So your answer is 100 pi inches cubed. For the next example, we're going to follow the same process. So I have to first find, we are given the diameter equals 10. So I can simplify that to have a radius of 5. So now the base is a circle with a radius of 5. So the base is pi times 5 squared. So the area of the base is 25 pi. Now the lateral area equals pi r L. In this case, we already found that the radius equals 5 and the slant height is the 11.2. So if I find my lateral area, pi times 5 times 11.2, again leaving in terms of pi, so we're doing 11.2 times 5, we get our answer of 56 pi kilometers squared is the first part of our answer. Now for surface area, it's the lateral area plus the area of the base. So the surface area equals the lateral area of 56 pi plus the base of 25 pi. So 56 plus 25 gives us our answer of 81 pi kilometers squared. Lastly, to find our volume is 1/3 the area of the base times the height. So volume is 1/3 times the area of the base is 25 pi times the height we don't know at this time. However, we could calculate the height because if I draw in the height, this is my height, this is 5 and 5 because it's split in half. So if I use Pythagorean theorem, because it's the right triangle, h squared plus 5 squared equals 11.2 squared, you get h squared is 100.44, and when you take the square root to solve, you get h equals 10.02. So if I substitute the 10.02 and you plug that in your calculator, we have 1/3 times 25 times 10.02. We get our final answer of 83.5 pi. So 83.5 pi kilometers cubed.